Hi everyone, I'm Atif, and today we're gonna like a small demonstration on DIY CNC which is happening in NYCCNC YouTube channel by John. So this is like a small continuation on how to use RepRap electronics, which means 3D printer electronics, to isolate our CNC machine from a computer. So basically that was the need on the last episode out there. So what we basically, the whole idea is to take out our machine from a computer. So the problem in TinyG or a GRBL board is we don't have a LCD, SD card or an encoder interface. So we have to basically switch it into 3D printer electronics like Ramps, Rambo. Today I'm going to use this Ramps1.4 board with Arduino Mega. Basically, since the TinyG uses an Arduino like electronics, it don't have much pin for a LCD or like kind of a thing. So what we're going to do is today we take a program out of a cam, we fit it into an SD card with the RepRap electronics. Now we'll talk about how to interface those with TinyG or a kind of electronics with RepRap one. Today I'm going to use the Ramps board. You can use DRV8825 stepper drivers, in which a TinyG uses DRV8818 stepper drivers, not much of a difference, both from Pollulo Texas Instruments. So basically we are not going to slice anything like slicer user, we're not going to use slices like slicer, Cura or Simplify 3D. Basically we'll take a code from Fusion 360 into an SD card and then into the RepRap electronics. The problem here is the Fusion 360 code don't directly run on a RepRap electronics. I mean the RepRap firmware like Marlin or Repetier. It has to be modified a little bit. We'll just take a look at the Fusion.
We are in Fusion 360 now. Let's draw a stock first, the raw material. R for rectangle. Select your plane. I'll just draw a rough rectangle. D for dimension it. I'll just give it as 150. This one as 80. I'll just stop the sketch now. Q for press pull. Select your profile. I'll just give it a minus 10 mm. That doesn't matter a lot. I'll just select the face and I'll insert an SVG file. Select your file. Insert SVG. Select your file. AIL. I'll just move around in the center. You can just scale if you want. Give it OK. So I'll just cut this AIL. So now I can just remove edit. You can just edit your sketch if you want to remove something like this. I'll just remove the 4 lines here so that I get a clear idea. Stop sketch. That's it. Now for a 2D engraving, 2D sketch is enough. You don't need to press pull or take a cut out of it. We can directly jump into cam now. Now here cam, I just first set it up. Now there are many ways of doing it. In a 2D operation you can engrave or trace, or in a water jet you can use that. Almost came out similar. So I'll just have a setup now. My stock is going to be from a solid. I'll just select the bodies, this body. On the setup side, I'll just give it as a lower left corner as my orientation, model orientation, z-axis and plane. I know this is going to be my z-axis and this is going to be my x on this point. So let's flip the z. Now it's x and y, satisfactory, good. Came out to be very good. Post process, I'll just give it a number. Program name as AIL Engrave. So okay now. So I'll try to go out for trace, which I am comfortable with for a 2D operation. All we have to do is select any tool, that doesn't matter as far as we are going to engrave. So geometry, we have to manually select all this. It's simple. Hold down control, even if not, no problem. We have to select all the profile. Yeah, that's it, done. So on a height tab you can just reduce the height or you can leave it as it is, no problem. The important thing here is on the linking tab you have to uncheck this lead in entry and lead out exit. If you have checked it, leave it unchecked. Now done. Now you will be generating your toolpath. Now you can see here that blue is your path, your engraved, and yellow and green are retraction and clearance. So quickly we'll just post process it. If you want, you can simulate, that's not a very big issue. That's not going to make much of a difference. I'll just post process it. I'll just select the post configuration is GRBL.cps, generic GRBL. My program number, program comment.nc is my extension, or you can use Gcode or .tap, no problem. You can just post it now. Now I'll just save it here. Yes, no problem. I'll just add it on. Now the most important thing here. Now we notice that I've tried this code on the RepRap electronics, which don't work. So the problem is, in a RepRap electronic, it expect G1 in every block of code, which means at the every start of a block we need a G01. So we don't have it here. So the basic solution is, I'll just find replace in files. I'll just find X, and we are going to replace it with G01 space X. So what we are going to do is, we know that on every line we have X. X is the starting coordinate system coordinate, so we will replace it by G01X. I'll just replace it here and replace. You can see that we find now we have a G01 command on every line. Now there is reference here. Now what we have here is everything straight line, no curves, arc, or circle. So there will be no G03 here. So in this one there is no G03. If you have a G03, why not Control Shift H, that is find replace in file. What I'll do is, I'll have a G03, G3, actually I'll find a G3 with a G01, what we replaced with that. What will we have, and then we'll have a X, all those things. What we'll do is, we'll find G3 with a G01 and we'll replace with G3. Same we have to do it for G2, G01, and we have to replace with G2. Currently we don't find any G3 or G2, which is a circle interpolation in Fanuc commands. Now we have to save it as file, save as. You can just save anywhere a file. Now the time is to feed it into an SD card and then to the RepRap electronics. Now we'll move on to the RepRap electronics now.
Now we are with my old Prusa i3 3D printer. Things are a little bit messy over here. This is the Ramps1.4 board. I'm actually using it with a A4988 stepper drivers. The power supply is from my Delta bot raw stock. This directly connected with this one. This we are interested in with full RepRap discount full graphics controller, which have a very good graphics for quick settings, positioning, extruder, and everything kind of stuff. So this is an actual printer. Now I have removed my print head to upgrade it to E3D. Now I have just plugged in a pen for 2D operation. This is more than enough. We are driving it with NEMA 17 stepper motors, X, Z, and all those stuff. So what we are interested in here is this electronics. This electronics is common. Now I have no thermistor, heat bed. You can notice here that no extruder, all those stuff. We can use it with 3 motors, bang on. So what we can do is, I have my AL Engraver on this SD card. I'll just plug it in. I just have to plug it in this way. I'll just have it. So we can, as any other CNC machine control panel has, on the quick setting, we have one setting for speed multiplier. So we can multiply our speed feed as, we can double what we have given it in Fusion 360. We can double it, or we can slow down it. It's like scaling kind of a stuff. I'll just let it to 100% over here. So this especially is a Repetier Firmware. You can use Marlin, which is similar to that. That's not a problem. We'll just now go and print it.